Okay, so we have our second problem here. We're tasked with the same thing. We have to determine if this integral converges or if it diverges. And if the integral converges, then if possible, we need to see what value this integral actually converges to. So we have the integral from 0 to infinity of x sine of x squared dx. So first things first, this is also an improper integral. And why is that? Well, this right here is the red flag, this infinity. So just as a heads up, any integral with a bound like this, if you see an infinity in your bounds, then that should be a red flag that this is an improper integral. And why is that? Well, infinity is technically not a defined bound for integration. This infinity is not a defined value for which we can evaluate this function. So what do we have to do? Well, we have to take the limit as b approaches infinity of the integral from 0 to b of x sine of x squared dx. And this is more of a notation thing than anything, because really this does not change the way we actually integrate this out, the way we do the antiderivative. The only thing that changes is that now we're just evaluating this function from 0 to b and then taking the limit as b approaches infinity. But nothing really changes about how we approach this function. It's more so of a notation thing, because technically it is incorrect to write this integral like this, because infinity is not a defined bound. That's the only thing that we're doing here with the improper integrals, if that is confusing you in any way. So now let's just go ahead and integrate it out. So this is a simpler function to integrate than our last one because of this x squared and x. So we see that there's a nice chain rule here that that's going to work out nicely when we end up integrating it out. And if you don't see it, well, hopefully you will after this setup right here. So let's go ahead and use u substitution because that's going to make the integral a lot easier. So let's set u equal to x squared, say. Let's just say u equals x squared, so that du over dx is equal to 2x right here. And if we do a little bit of algebraic manipulation here, then we can get dx over on this side, 2x over on this side. So we get dx is equal to 1 over 2x times du. And now we can plug in our u wherever we see x squared in our integral, and then we can substitute this dx for what we just solved for as the equation for dx. So we can get the limit as b approaches infinity of the integral from 0 to b of x sine of u now, because u, we're replacing x squared with u now. And then let's just replace our dx with our formula for dx, so 1 over 2x du. And what do we see here? Well, these two x's cancel out very nicely, and we're left with the integral, technically the limit as b approaches infinity, right there, the integral from 0 to b of 1/2 sine u du right there. And this just becomes a very straightforward integral. So we have negative 1/2 cosine u, which equals, if we go back and plug in our x squared now, that equals negative 1/2 cosine of x squared. And we evaluate that from 0 to b, and then take the limit as b approaches infinity. So let's just go ahead and do that. Negative 1/2 cosine of b squared minus a negative 1/2. So let's go positive 1/2 cosine of 0. Now what does that leave us with? Well, that leaves us with 1/2 minus 1/2 cosine of b squared. And now, if we take the limit as this approaches infinity, then we get 1/2 minus 1/2 cosine of infinity. But what is 1/2 cosine of infinity? Well, that's undefined, right? Because cosine is an oscillating function. So we see that this actually does not ever approach a finite value. Cosine never approaches. We see right here, if we were to graph cosine on this xy plane, cosine just oscillates up and down forever and ever. So this function, as it approaches infinity, it never really approaches a finite value. So because it does not approach a finite value, then this function actually diverges right here. So that's an important thing to note, that a function doesn't just have to go to infinity to diverge. Functions like sine and cosine, they fit the bill for a diverging function, because while they never actually reach a crazy number, a crazy undefined number like infinity, they never converge to a finite value. They're always oscillating, always changing, in this case from -1 to 1, and then just back and forth like that. So there you have it, integral of x sine of x squared dx. We find that it diverges, and then we're done from there. We can't actually calculate a finite value from this.